Now we're going to talk about calculating how humans interpret the loudness of sound. This also sort of applies to how humans interpret the brightness of light, but we don't really have the same sort of calculation for that, at least that we're going to do. So we're mostly going to be talking about sound. Now, it is related to the intensity of the sound wave, but if you hear two sounds, one that has an intensity twice as high as the first, it doesn't actually sound twice as loud to a human. And that's because humans have what's called a logarithmic scale of input. And this is just a feature of human sensory organs that allows you to sense things over a very wide range of magnitudes. And since you can hear things that are very, very soft and things that are very, very loud, a separation of about 10 orders of magnitude, what that costs you is the ability to distinguish relatively small changes of loudness, meaning a factor of 2, for example. So, what we do when we're talking about how sound changes for basically human ears is we calculate this in terms of decibels, which is a unit I'm sure you've heard of. Now, first, to start with, a decibel actually is, in terms of an SI unit, really using the prefix deci. So, in principle, there would be a unit called a bell, which would be just a plain old B, but no one uses that, right? So the deci really does mean a tenth of a bell. So we're going to be multiplying by a 10 in order to convert from sort of the SI unit into decibels. So the first thing we need to do is to define a scale with which we will measure all intensities. And the scale factor that we use is called I naught. The little zero there we pronounce as naught. So I naught is defined by 1.00. There's an extra sig fig there. 1.0 times 10 to the minus 12 watts per meter squared. This is the smallest intensity sound that an average healthy human can hear. And you can see that it's a very low number, 10 to the minus 12 watts per meter squared. Now, we're going to define what's called the sound intensity level. This is the thing that is measured in decibels. So sound intensity is I, sound intensity level is beta, and it's found by taking the log base 10 of I over I naught, and then you multiply by 10, and the units are going to be decibels. There's that 10 I was talking about when you have a decibel. So, we're going to practice some calculations here. So we're going to have three different calculations here. So the first one is to see how many decibels is the smallest sound a human can perceive. Now I'm going to challenge you to pause the video before I compute a calculation with you to see if you can do it on your own before I catch up. So we're just going to follow this calculation. So B equals 10 decibels times log base 10 of I over I naught. You don't have to write the base 10 every time. That's just so you know for sure which one we're talking about. So this is times log. So we're setting I is equal to I naught. So I naught over I naught. And you should know that log of 1 is equal to 0. And if you're not sure if you know that or not, you can just do log of 1 in your calculator, and it will remind you that it's 0. So this is 0. So 0 decibels is essentially the definition of the smallest sound that an average human can hear. Now, negative decibels exist, right? If you had a sound smaller than that, so for example, if you had I was equal to 10 to the minus 15 watts per meter squared, then you would have beta is equal to 10 decibels times log of 10 to the minus 15 watts per meter squared. Sorry, I'm squishing this in there. 15. 10 to the minus 12 watts per meter squared. That doesn't really fit, but okay, so 10 times log 1 e minus 15 divided by 1 e minus 12. And so this is negative 30 decibels. This is just a plain old, normal, real number that exists. Sounds can have this sound intensity level. It's just that a human probably would not be able to hear it. But you could have computer equipment that could hear it. I doubt many animals could hear it, but, you know, it exists. Let's go ahead and do another calculation. So this is normal conversation between two humans that are 1 meter apart, and you can see that it's 10 to the minus 6. So beta is equal to, again, you can pause it, do this calculation on your own, see if you can do it. 10 decibels times 10, or times log. I don't know why I keep writing log strangely. 10 to the minus 6 watts per meter squared over 10 to the minus 12 watts per meter squared. At this point, you might know how logs work, right? So this is going to give you a 10 to the 6. Log base 10 of 10 to the 6 is 6, right? So this is 60 decibels. So you don't actually have to type all this into your calculator. I'm giving you numbers that work properly like this. But if you're not sure, you can do 10 times, I can't find log now, log 1e minus 6 divided by 1e minus 12. There you go, 60. Okay, and then finally, a rock concert. This is getting up towards the edge of what humans ought to be listening to. Much larger than this, 130, 140 range, and you will be damaging your hearing. If you've listened to this for very long, you'll be damaging your hearing. But here we go. 10 decibels times log. There we go. I wrote it like a normal person. Oh, I'm sorry. I went the wrong way. Maybe I'll edit this, but probably I won't. Okay, so we're doing the calculation the other way, right? So we're going to have beta is equal to 120 decibels, but that is also equal to 10 decibels times log of I over I naught, right? So we're going to solve this for I. So the first thing we do is divide by 10 decibels. So we get 12 is equal to log of I over I naught. The way you undo log is to raise both sides to 10, right? So we have 10 to the 12 and 10 to the log of I over I naught. 10 to the log cancels out. So on the left-hand side, we have 10 to the 12. And on the right-hand side, we have I over I naught. Right? And now we can multiply that across. So now we have 10 to the 12 times, and I naught is 10 to the minus 12 watts per meter squared is equal to I. So if I is equal to 1 watt per meter squared, that would be equivalent That would be equivalent to 120 decibels. Sorry about the focus again. Okay.